Hello and welcome back to the Life Stages Theater. Our final session of the day is Space Travel Science to Engineer Anti-Aging Solutions, presented by Dr. Bajit EDS, Laboratory Director at the Japanese Society of Anti-Aging Nutrition. This presentation will consider extreme environments as a source of research and develop next-generation technologies, how microbiome therapeutics from space to Earth could be the next anti-aging solutions, and an applications model bringing an edge to formulations of life science products. Without further ado, Dr. EDS, you have the floor.
Thank you very much. Thank you for the opportunity. Thank you for this chance to share this interesting research. So I will share with you the genesis of this project, which is space travel first. So a few years ago, there is NASA clinical trial that has been done in twin astronauts, identical twins. One of them went to the space while the other remained in Earth. And later on, when we test the DNA and the microbiome of the astronaut who went to the space, we found that it has been modulated. He has also beta cell twins, and everybody was thinking, oh, this is traveling in space has very good advantage for longevity. And I think the media communicated this, that some people was saying, oh, traveling in space is allow people to live longer. The other side, the untold story, is space travel make that the same human lose bone density, lose muscle mass, and this is, we are talking about significant amount of like 1% in a phase of staying 2 weeks in space. So when we try to understand why this stress in space can modulate this microbiome and change this foundation of the human body, we found it boiled it down to one point, is evolution. Evolution of the microbiome during stress. Going to the space, there's several types of stress. The oxygen type, the ecosystem, which is completely sterilized and decontaminated, the gravity, of course, which is affecting a lot the human body, but also radiation, which is quite much higher in space than in Earth. We found that microbiome under such stress start evolving much faster. And this evolution allow them to create new metabolites, a new what we call postbiotics that affecting the gene expression. So the genesis of this study is the extreme condition and the stress that allow the human to be in better shape, which is very paradox because everybody normally talk about the relaxation and less stress and less cortisol. And here we found the phenomena, the opposite, the paradox, which is by exhibiting the human to such extreme stress, they can improve their health condition. There is another study done by French wine maker Petrus 3 years ago when they brought the wine to space, and after staying almost, initially they wanted to leave it for 6 months, but with the corona it stayed for 1 year. Bringing it back to Earth, found that comparing to the wine that has been kept in Earth, the wine in space has evolved and aged much faster. So definitely there is acceleration in the process of aging because the microbiome, they become more active and they evolve. And the taste also has changed. It means the same microbiome are able to produce new actives, the new metabolites. So for us to validate this hypothesis, we try to test more easy subject. It is not easy to test the astronauts every day. So the main target I focused on is the Everestist, the people who go to Mount Everest. It takes 2 months of preparation at least, and then they go to the Mount Everest 1 week after they come back to their countries. So the sample studies is we apply it to French alpinists from Chamonix, 3 men and 1 woman, and we try to see how the microbiome before going to Mount Everest and after. This is a very stressful trip. Oxygen deprivation, hypoxia is very easy to happen because of less oxygen at high altitude. And it's quite very cortisol infused trip, you know, going to Mount Everest is not funny. We found clearly that the microbiome of these people has been evolved, and we can measure it easily by the metabolite, the postbiotics they are producing. And when we take the faces of these people before and after, definitely it is this person has been transformed. Now, is this transformation going to remain with them long time? This is the test of gene expression and epigenetic that we start testing. And we found that this modification, this gene expression can stay with them for some time before slowly starting declining because the initial stress source is not there. So the point is start with us to understand how these postbiotics of such stressed people can affect others. So we start taking this microbiome from such a highly stressed person like the astronauts, the Everestists, and try to move them into fermentation platform, get the postbiotics, apply it to average human to see how can we move from weak microbiome to much stronger version. So the microbiome system or the probiotics here at the expo, and thanks to George of IPA, he's bringing a lot of people from the probiotic industry. We can see that the probiotics have impact in human body, but the direct impact, it's happened through their capacity to metabolize whatever food, nutrition into postbiotics, which will act into the gene expression level and create a new action from, if they produce some amino acid like GABA, we can predict that they are going to bring more relaxation for the human, etc. So the postbiotic for us was the key point of these studies, and because we think this is the only way that allow us to bring something unique among every human, which is the genes. Humans share the same genes, the same DNA, etc. So we try to move from testing the microbiome itself to test these postbiotics and try to see how can we take this microbiome and put them under specific pressure, like space pressure. So now at the moment we're having a project going to bring human microbiome from Earth through NASA platform to space. We call this project Astrobiome in collaboration with Mars Design City. And the aim is to see how can we bring this microbiome back to Earth, re-implant them into the same human where we take them to avoid the human to live the stress, but let the microbiome live the stress. And in this case, we can see the change that can happen in the human evolution. This is the fermentation reactors that we have installed in our labs in Tokyo. So our aim is simply to take this microbiome after return from stress, put them into a fermentation process, get the postbiotics, and then try to validate its efficacy in skincare or health or pharmaceutical products. So it must have very quick result if we use the gene expression as a platform. It does not take long time. We have several successful models of this stress. Like here, I'm sharing with you the one of the Lactobacillus subtilis, which we extracted from palm tree from south of Spain. Palm tree living under a lot of stress, no water, and a lot of UV. And when we move such microbiome into fermentation, getting the postbiotics, we was able to find some solution that can affect the mitochondrial gene expression in the skin. We move into clinical trial to validate that we can get some gene expression result, and we have very successful model that we are going to publish later in September. So the aim of all of this study is to try to bring more knowledge about the evolution of the microbiome. A lot of people study the microbiome at the baby level, and when the 1,000 days after woman deliver the baby, and try to see how can they modulate such microbiome. Then the stage of the human age, adult age, 20 to 50, where we try to solve some health issues through such microbiome. The most interesting is the evolution through 50 to 100, and at this level we can notice clearly that the same microbiome from the baby level have been evolved. And that's why a lot of studies, even 5 years ago, saying it is irrelevant to test microbiome because they keep changing. And I think it's not changing, but evolving is the word that we need to understand. And they evolve according to the condition that the human can experience, from stress to physical challenge to life challenge, etc. We try to bring focus that beyond the probiotics, we need to look about what each probiotic can produce. And this is how can we KPI the evolution of, in term of a human term, we call about the result of a company or result of a human performance. And I think in terms of probiotics, we will start talking about how can we evaluate the probiotics performance in terms of their production of postbiotics. Same probiotics, same strains does not produce the same thing, very similar to human performance. So we try to use for that a platform, artificial intelligence platform, which we call Gen Sonar, that allow us to see all of these thousands postbiotics, metabolites, and how can they affect the gene expression, alone or combined. And this is very amazing science, because this will allow us to start producing highly effective food supplement, health food, pharmaceuticals at very low dosage that can go to 2-3 milligrams of some bioactives, opposite of 500 or 600 or 1 gram of bioactives. We validate all of this microbiome modulation. So beyond bringing some microbiome probiotics from the outside to the inside and do our best to make them surviving, we try to just modulate the existing one, relifting the existing one, and make such tests by testing the amount of postbiotics metabolites produced that we can collect from human skin, faces, or in vitro in the lab. Here, a study I share with you about mood expression. A lot of people ignore always that a lot of serotonin is produced, start production from the skin to the guts to the brain. So the main catalyzers are probiotics, bacteria, strains, microbiome, who are able to connect in a very complex language, which we call the quarium sensing, communicate together to be able to produce some hormone that can modify the human psychology, actions, success, failure, social life, capacity of the collagen to be synthesized faster or in better quality. So we think that the human brain, human body can be completely modulated by the microbiome improvement. I leave you some time for if you wish to ask me some difficulty question. I'm at your service.